Hello everybody, this is the tutorial video for the application of Chevo. Chevo means channel evolution, and it is a tool which was developed in HyMoCARES for the analysis of morphologic changes between cross-section surveys. Chevo is part of the multi-scale concept for sediment-based river restoration, which was developed in HyMoCARES. And you can access Chevo on this website, hymo.azurewebsites.net. Click here on Chevo and you can here enter your data on cross-section surveys. Let's look how the cross-sections data needs to be prepared. You need 3 columns of data. So you have here the cross-section name. You can also have letters in it. And it's just one cross-section after the other. So here you see cross-section number 512, and then there is cross-section number 510. And in column B, you have the lateral distance. In column C, the elevation above sea level. So we can look at the cross-section as an example. This is how one cross-section may look like. And when you save the file, you need to save it as a CSV file so that it is compatible with Chevo. And then you can upload your files into Chevo. You upload one file for the cross-section geometries from the earlier survey and the other file from the later survey of the same cross-sections. And then Chevo needs the water surface elevations of the channel forming discharge. The channel forming discharge in the alpine rivers is about a 1-year flood, or you can also do more accurate calculations of the channel forming discharge. You can look up the deliverable DT221 of HyMoCARES. You can use own water levels. For example, if you have applied a one-dimensional model and you want to use these water levels, you can upload a file here. This file needs to be prepared like this. You have here the cross-section name or a number. Then you have the water surface elevation of the channel forming discharge in the geometries of the earlier survey and the water levels in the later survey. If you don't have own water levels, you can also apply the modeling in Chevo, but you need to consider that it is useful for channels where you can say it's more or less a uniform geometry. And here you need to enter the discharge of the channel forming discharge. So this is in our example 1404. Then you need to enter the Manning value for roughness and the channel slope. Then you can click on the Run button, and now Chevo is calculating the water surface elevations in our cross sections for the earlier and for the later survey. You see here the dashed line, which is the earlier cross section, and then the cross section at the later survey. And you also see how Chevo measures the bank erosion. It measures the horizontal distance between the water edges for the left bank and for the right bank. And it also measures the distance between the middle of the water surface from the earlier survey and the middle from the later survey, which then determines the channel migration. And then on the left side, you can see the channel evolution diagram. And when you click through the cross-sections, you can see the highlighted points on the left side. So you Can read here all the data about the channel changes, and the channel evolution diagram consists of 8 axes. So the idea was to be able to read as much data on channel changes at one glance as possible. So you see, for example, this cross section, it had a right bank erosion of 14 meters. You see here the axis, and the left bank erosion of 14 meters. So it's to be read on this axis. And then you can also use these diagonal axes, channel widening, it's about 31 meters, and channel migration. You read it on this axis, so it would be here. Channel migration would be to the left, which is about 1 meter 34. Additionally, the color of the dots tells you about the state of vertical development. So if there's a red color, you have aggradation. If it's rather blue, it's degradation. So in this example, you see here that the widening caused an overall aggradation of the riverbed. So you can click here through all the cross sections. You can also save the images with a right click on the mouse. Also, this image here can be saved. And you can download all the data in tables. You have here all the data in the cross sections for the earlier and for the later survey. Here you see the cross section name or number. And you see here the position of the left and right water edge. You have the water surface width, the water surface elevation, the mean bed elevation, and also the number of channels. So if there is an island in between, you would have the number 2 here. And you can also look at the data from the latest survey, and you can look up this table, which was used in the channel evolution diagram. Again, the cross-section identifier, and you have the left bank accretion. So if it's negative, it is erosion. Here the same. So you have it's all negatives. You had a lot of widening. You see the widening here. If these numbers would be negative, this would be narrowing, but you have widening here. Here these numbers are positive if it is a migration to the right side, and you have the bed level changes in the cross sections and the water level changes. Thanks for watching. You can find more information on the project HyMoCARES with this link. My name is Mario Klösch. If you have any suggestions for improvements or questions, you're very welcome to contact me. And you can also find more technical information on the tools with these 2 deliverables of HyMoCARES. Thank you very much. Goodbye.